Welcome back to Workshop Friend, and this is part 3 and the final part of making a set of tool holders for my shaping machine to enable me to more easily cut keyways in pulleys and gears. I've assembled the bar in the holder, and backtracking a little bit, the clapper box is here, and I measured this hole and I've turned this to size, but it just doesn't quite go in. It could be just a slight burr on the lead in there, but generally speaking, if you make size on size, it's not going to be a nice fit. So I'm going to take maybe 1 thou off this and hopefully bring this to size, and hopefully this is concentric enough to be able to do that. Just in case I do need to put this back in, I'm just going to mark the position in the jaws. So in part 1 we made this holder and the nut, and that basically comes in from the rear of the clapper box like this, and we can use this C-spanner to tighten it up. And then the tool holder that comes in here with a 10mm socket head cap screw from the rear, and then finally these 2 clamps to restrain the clapper box, because we don't want the clapper box to open. So that's our setup. I still have to drill the hole in there for the tool bit and the set screw in the end there to lock it all up. Now I've actually gone ahead and made a couple of smaller size tool holders. So there's an intermediate one and the small one, and actually that small one is the original one I used to use, but with this adapter on the end here. So the problem is that we need some kind of restraint to be able to tighten up the 10mm socket head cap screw, and this time it actually has locked up and it's tightened, but it doesn't always. But even if that has, I still need to have some kind of restraint to be able to tighten up the large nut, and conversely to be able to undo it conveniently. So yeah, now it's slipping, so I'm not able to easily undo the nut. So either the whole assembly slips in the clapper box, or the tool holder rotates in the tool in the holder here. So I need to have some kind of restraint. Now I've got enough material here on this 1-inch diameter flange to cut a hexagon on there, so we can put a spanner on there to restrain it, and what I'm proposing to do is to do that on all 3, and then that will give me some way of locking the assembly up, other than putting some more grips on there and messing it all up. So I'm going to take this out, put it in the mill, and machine those hexagon flats on there. In fact, we'll do all 3. So this is my little 3.5-inch universal Victoria dividing head, which I got about a year ago, and I've used a number of times and I'm very happy with it. But there's one curious feature: there is no option for locking the spindle. So not that there's a lot of backlash, so I've just set this DTI up on my 3-jaw chuck on one of the jaws there, and we get about 1.5 thou of total backlash. And I've actually tried it in 3 locations, and it's pretty consistent around the circumference. By dividing that into the circumference, that works out at 0.044 degrees, or roughly 2.5 minutes of rotation. And I don't know if that's typical or not, or whether that's significant. Now I think there is some adjustment possibly on the worm wheel, but I need to have a look at that, and I haven't got time at the moment, but it's just an interesting thought. I wonder why there is no spindle lock, and whether that degree of angular movement is excessive or not. Certainly for what I'm going to do today it's not. This land here is 1 inch diameter. It's the original diameter of the material I cut this from, and I want to cut the hexagon to 0.866 across flats, which is the maximum across flat size I can get from 1 inch diameter. That means I need to touch off and then come down by 67 thou, or 1.7 millimeters. This is in fact a metric machine, so I'll be measuring 1.7 millimeters. I won't do it all in one go. I'll take several cuts, and I'll put a mark on my dial to make sure I bring each side to the same depth. This is probably old hat to most of you, but just in case it's helpful for someone, I'll just explain how I'm going to use the dividing head. So the gear ratio is 40:1, so 40 revolutions of this rotates the spindle once. And we're looking for 6 sides, so that's 40 divided by 6 gives me 6 whole turns of this plus 2/3. Now to get that, I need to make sure that I've got a number of holes on my plate here, which is divisible by 3. So I've got here 21 holes on this circumference, and I've set these up to measure out 2/3. So that will be 14 holes, which is 2/3 of a revolution. So what I'll be doing is I will be starting out here, counting 1, 2, 3, 4, 5, 6, and then 2/3. So next time I'll start from here, but before I do that I'll swing this around. So we'll go 1, 2, 6, and then 2/3. So that will give us our 6 divisions, or 6-sided hexagon shape on the work. So I've machined the hexagons on all 3 tool holders, but now we can assemble these. And we can use this to tighten it up now fully. So that's that part of the job done. Now I've discovered something else. I thought I'd be able to use either this or this to restrain the assembly while I tightened up the large nut, but I was mistaken. I thought it would be between one or the other, and sort of tightening them up sufficiently to provide some restraint for this, that I would get away without any further restraint. Now sometimes it works, sometimes it doesn't. Let's just see if I can undo this. Okay, that illustrates the point. Now here you see the whole assembly's rotating, so the friction of the tool holder in this body isn't sufficient. Now sometimes I can restrain it like this, sometimes I can't. So what's happening now is that the tool, this is now come undone and this is still locked up. So it's very inconvenient, this. Now let me get this apart off camera and I'll show you what I'm going to do. So what I'm proposing doing is using an end mill to come in there on the circumference as the center line and machining down to this flange, this depth here, maybe slightly beyond. That will simultaneously give me a radius in here and a radius in here. Take this out, and then what I want to do is open that radius out, and let me explain why. So hopefully you can recognize the parts here. We've got the clapper box here. Here it is in the background. We've got the holder here going in, and you can see the semicircular part of the key here, which goes in there, provides a nice locking feature. And I'm going to open up the semicircular feature in the circumference with the same end mill to create a square slot. And the idea there is that it just gives me a more rigid location. So this will be a clearance, and this will be either Loctited in. Ideally I would have silver soldered in, but I haven't got a torch here at the moment. So I'm probably going to soft solder it in. I think that would be more than adequate. The idea there, it just gives me a more rigid key. It means that I only have one clearance, and that's between this and the hole. And given that this is a round hole or semicircular hole, I think two semicircular holes together would have just, I don't know, just mechanically it's not so good. There's a tendency for the two parts to push away. This way that's minimized. So it's over to the mill and try and set this up for that operation. So this is my setup. I've got the clapper box in my vise. I've got a couple of jacks underneath here to get it level. But before I do that, I'm just making sure it's square in this axis. So clocking up the top surface there, and then I'm going to clock up in this direction. You may be wondering why the complicated setup. Well, that's because I didn't want to dismantle the clapper box, and in overall terms this seems to be the simplest option for me. So I put a 5mm slot drill in. I'm just going to touch on the top of the mild steel component, the holder, and then we need to go down 9.8mm. And then afterwards I'll follow up with a 1/4 inch end mill. So I want to just flatten out the bottom of the hole and take a cut in this direction. So to do that I've got to remove the bush. So there we have our hole just below that ledge there, which is what I wanted. Then we've got the beginnings of the keyway in the tool holder. So what we need to do now is square that off and make a key. Well, this isn't going to be critical. I just need to make sure that this is vertical. I'm going to put my rule across there, but before I do that, just make sure that the burrs are removed. Surprisingly sensitive, actually. It's certainly not worth going to a lot of trouble. I think this is going to do the trick. So I'll tighten that up now, and then what I'll do is I'll just bring the end mill down in the center of that slot and cut it to depth. So at last we've got the parts ready. So this is the radius part of the key, and this is the other part, and it took a little while to make this key. It's a bit fiddly, but you can see that's a nice fit in there. In fact, there's no play that I can detect. Not that that's particularly important, but just kind of a sense of personal satisfaction, I guess. So what I'm going to do now is to join these two together, the key and the tool holder. Originally I was going to soft solder them, but I think it might be better to avoid getting lead on here, just in case subsequently I do want to silver solder these together. So I'm going to clean these up and Loctite them together. Now I'm going to put the unmachined face outwards because we can tidy that up afterwards, and the machine face I'm just going to bring up just short of that shoulder so we don't have to tidy that up. So I'm finding the center of the shaft ready for center drilling the cross hole, and then I'll transfer it over to my drill to finish off, and that's because I don't have enough height on my mill. And the medium-sized tool holder, I'm reaming here to diameter 3/16 of an inch. And similarly, the larger tool holder I'm reaming out to suit 1/4 inch diameter tool bits. Okay, last operation now is just to drill and tap for the set screws. This one is 5mm. The larger boring bar, this one, has a 6mm set screw. So we'll just run through changing over the tool holders. So removing the regular tool holder, just like that, and then inserting the new one with lining the key up like that. And of course, once you've set the tool up in the holder, it automatically is in the right position because of the keyway. And then finally, all we have to do is just install the 2 clamps. And that is rigid. Of course, we've got the 2 alternative bars here for larger diameter work. Well, that brings this series of 3 videos to completion, just in time for receiving my Colchester student lathe. I had news this week that it's due to arrive here on Monday. It's cleared customs. I'm waiting to see whether the box has been opened on the way and everything is safe. So I'll open that up with you in the next video and show you the process of me setting it up here. So thanks for your support and comments. Do keep them coming. I look forward to seeing you next time.